We've been looking at triangles like these, right triangles, and using SOHCAHTOA, we can figure out angles and sides, which is pretty cool. But what about a triangle like this? A triangle like this is not a right triangle, and suddenly SOHCAHTOA won't work. The reason it won't work is that this triangle does not have hypotenuse, so we don't have the opposite and adjacent. We don't have these three sides, so we cannot use these ratios. We need to find something else we can use. And we actually do, so let's look a little closer. I'm gonna look at closer, another non-right triangle, and there's this cool thing called the law of sines, and that is this, all right? If you've got a right triangle, and let me first actually label a little bit better before we explain that. You have the opposite side, so angle A, opposite of angle A going directly across is little a, and opposite of angle B going directly across is little b, and opposite of angle C is little c. So we're just using A, B, and C instead of hypotenuse, adjacent, and opposite. And if we do that, we can build three ratios between the angle, the sine of the angle, and the opposite side. And all of these ratios are equal. So again, we have ratios and we can use ratios to solve triangles. So let's do that right now. I'm gonna give you a triangle. Now, first thing I have to do is label A, B, and C. You can choose them to be any corners, just be consistent. So if this is A, then little a is right across. And if this is B, then little b is right across. And I'll make this C, and little c is right across, okay? Now, what I'm gonna be interested in is I would like to find A, okay? How would I find A? So I'm gonna use these ratios. First thing is there one ratio that I know both parts of, the A, the big A, and the little, and that would be B right here, okay? So I know the B one, which is awesome. So I'm gonna use that. So I'm gonna focus just on these two ratios, the one I'm interested in, which is little a, and the big B. And when I do that, I can fill that out with the actual numbers, and I get something more like this, okay? So now I've got the ratios. Now I circled these to let you know how I can solve it. And I don't know if you remember this, but with fractions, you can cross multiply and get an equivalent equation, still equal. So I'm gonna do 10, the bottom number, times the opposite of the top number, sine 80 equal to A, and I always put the number or the variable in front of the trigonometric expression, A times sine 40. Okay, that still does not look very solvable. But if I get A by itself, if I could get rid of that, I would know what A was. So this is timesing, so I'm gonna do the opposite. I'm gonna divide this by both sides. Okay, so now I have, this cancels out. So now I simply have 10 over sine 80 over sine 40. Still looking pretty funky. So I think it's time for my calculator. So I'm gonna plug all of that into my calculator, and when I do, I get 15.32. So A equals 15.32. And I can write that right here. So I now have that side. What I don't have now is C. So I could actually find C. The problem with C is I don't have either piece of information, right? But I could find one of them pretty quickly, okay? If you remember the triangle sum theorems, let's move these out of the way. Angle C, right, is gonna A plus B plus C, they all equal 180. So I can just go right ahead and solve and figure out what is that. And if I do that, I find out that C is 60 degrees. Okay, so now I know C. Now I still need to find my little c, so let's put 60 degrees here. And I just need to find that little c right there. I have one ratio already solved, actually two, but I'm gonna stick with B. So let's go ahead and use sine C over C equals sine B over C. So we just go ahead and plug that right in here, okay? Okay. And we do that cross multiplying again. So I'm gonna get 10 times sine of 60 equals C times sine of 40 degrees. I'm going to divide, I want to get C by itself, so I divide both sides by sine 40. Okay, and then we end up, that cancels out, so C equals, it's going to equal this term right here, so you can go ahead and put that in your calculator, and when you do that, you end up with C equals 3.47. So C equals 13.47. I now have solved every angle and every side. So this is a great thing to know. So you might actually want to put it in your notes so you can use it. So So let's grab your notes out. And here we've got the law of sines right here. If you would like to have an example in your notes, here is an example problem right here. Okay, so we're trying to find out, again, let's just, we'll solve for A. To do that, we need to know one ratio. So I see here I have an angle and a side here with C. Okay, so what I will use then is sine A over A, the ratio that I already know. I set that up, fill it in, cross multiply, divide by 70, and I get my answer for A. There you go. You now know the law of sines.